Hello and welcome to this talk. First of all, we would like to thank the organizers of iOS Conf Singapore for organizing this conference in these difficult times. We know how hard it must have been, so we really appreciate your work. Thanks a lot. Today, we would like to talk about XCMetrics, the all-in-one solution to track Xcode build metrics. My name is Patrick, and I'm an engineer at Spotify working in the Foundation Squad in Stockholm. My primary job is focusing on the developer experience for our iOS engineers.
And my name is Erick. I am also based at Stockholm, and I work with Patrick.
First of all, let me give you some context about Spotify. We currently have about 4 iOS apps. We have 130 monthly contributors to the iOS applications in our repos. And the main application, which is probably the one you're familiar with, it's the Music app. It has about 1.6 million lines of code of Swift and Objective-C. Currently, it is about 25% Swift, and it's always increasing. So we previously mentioned that we work on developer experience. So what is developer experience? Developer experience can be defined as the equivalent of user experience when a primary user of the product is a developer. So our primary users of the tools that we develop in our team are the other iOS engineers at Spotify. So we mentioned also that our job is to improve the developer experience. So how do we measure that? How can we make sure that our job is successful? First of all, we have to think about how we can measure that. We can't improve what we can't measure. So we need to find ways to measure the developer experience. And historically, this has been pretty hard. How you work and how you think you're working and how productive you are is very subjective most of the times. So we are trying to find some data to make sure that we can measure that. One way to do that is the feedback pyramid. I really like this image by Balestra, who is an engineer at Slack, which he shared in one of his talks. The feedback pyramid allows us to find different ways to see how the development experience is doing. At the bottom, with the highest volume of data is telemetry, which is just the collection of data, which we're going to talk about in this talk. It's a low effort way of collecting data, but the detail and the bias is also very low. Surveys, on the other hand, are another way of collecting data. We simply go to our users and send them a survey and see what their answers look like. So this takes a bit more effort because we have to prepare and send a survey, but we can get a bit more details on the type of answers that they will give us. Listening is, of course, the lowest amount of data that could give us. And it's also very high effort. So we would need to go to our developers and have one-to-one like meetings with them and understand how their developer experience is going, how productive they feel. But of course, this can also provide us a lot of details about the problems that they're facing, which we would not be able to otherwise gather via telemetry, maybe.
So a bit about the story. Back in 2017, we started researching adding Swift support to the Spotify app. So Patrick already said, it's a big app. It has millions of lines of code. It's been around since 2008. So every time we introduce a big change like that, we are really, really careful and we consider a lot of risks. In this case, our squad focuses on the developer experience. So we wanted to be sure that by making this big change, the developer experience was actually improved and not getting worse. And basically, we wanted to have the ability to help the adoption of Swift in case things were wrong, like imagine that we introduce something that increases the build times for a lot, or that introduce a lot of build times errors for some developers and so on. So we wanted to avoid that situation. And if you remember when Patrick talked about the developer feedback, there are different ways of getting it. So yeah, of course, we do surveys. And in this case, because the change was really big and really risky, we actually did as well some user research. We invited developers to work with us in our squad area, sitting just next to us to beta test the changes that we were introducing. And we collected feedback from them. And we observe how they worked, with which kind of roadblocks did they found, and so on and so forth. But as Patrick mentioned, that is hard to scale. At some point, we realized that that kind of data is valuable, but we needed more. We needed this telemetry part. We needed to collect objective data about how the developer experience of our engineers was. Because at some point, we felt like we were taking decisions blindly. Okay, yeah, we cannot invite everyone to work with us at our squad area. Everyone is located in different offices. That doesn't scale. We can do local tests. Yeah, that's okay. But we actually needed to have all the data. We needed to collect more things about it. And then at the end, we wanted to have some kind of way to do A/B test at the infrastructure level. So imagine that you introduce, I don't know, something like you pass a new flag to the Swift compiler, and you want to check that actually worked to improve the build times, for instance, and then decide based on the data what to do to roll that change to everyone and to roll back. And when you work as an iOS developer, basically your main tool is Xcode. And Xcode is great for local development in the sense that it gives you a lot of feedback about what's going on in your builds and when you run tests. And for instance, you have the console log and you get all the logs there. You also have this report navigator window where you can see stuff like the build times. I don't know if your Xcode project has build phases scripts. You can see the outputs, you can see the errors, the detail of the errors, the warnings, everything. So we started to think if it was feasible to extract that data out of the IDE. And basically we found a way to do it. We found that Xcode dumps everything, all that data, into a log in the derived data directory. That log has the extension of XCActivity log and is written in a format called SLF. So basically what we did was to create a Swift project, a Swift command line tool that parses that log and transform that log into different kind of reports like JSON, like HTML with some nice charts to get some insights. We open sourced that tool back in summer of 2019. And here is an example of how that works. So imagine that you introduce a change locally and you want to check, for instance, you introduce this flag for the Swift compiler and you want to check that the build times decrease or something. And you build with Xcode. And after that, you can go to the command line tool and run xlog parser. And the tool will find the latest log for that project. And it will transform that into the report that you pass as an argument, in this case, the JSON thing. And of course, you can also pass the path to the XCActivity log if you know it. And you can see here, basically, when I mentioned that Xcode dumps everything, I mean everything. You have a lot of data there. You have dozens of thousands of lines, and in some cases, you have build times, you have warnings, errors, everything is there. So we started to use that locally. So basically, the way we did it was to run some local tests and then output the data with the xlog parser to get the data from Xcode. And it was good. It worked. But then how can we collect that? How can we use xlog parser in all the developers' machines of our engineers?
So the answer to that is XCMetrics. Today we are excited to open source XCMetrics on GitHub. It's available today, and we would like to explain to you what is it and what it can do for you. So XCMetrics is a way to keep your build times under control and monitor which targets are taking the longest to compile in order to improve the developer experience. Not just that, but as Erick mentioned, xlog parser and the XCActivity log file format contain a lot more information. So you can also collect warnings to improve your code health, see which warnings are coming from which targets, and see even which errors are impacting developers. So you can actually diagnose build problems in real time. XCMetrics collects a bunch of information by default from Xcode, but it also collects a few more information that we think are really useful for debugging problems, such as hardware information and Xcode versions and optional tags. In this way, you can actually see which builds were produced on which processor, for example, or how much free RAM was available at the end of the build, on a particular machine. Also, we support having custom plugins, so your team can write infinite amount of plugins to collect any type of metadata that you would like to attach to every build, such as, for example, Git information or project generation statistics. In this way, you can try to build a full developer journey and understand why some builds are taking more time than others, or why some developers are facing certain problems in their local repositories. XCMetrics is composed by two components. There is a Swift CLI, a command line tool that runs on developers' machines. And then there is a Swift backend service, which is written in Vapor, a Swift backend service framework, which runs on your backend service, which will collect all the logs. And now we're going to take a look at a small chart to see how everything fits together. So Xcode will produce a XC activity log file in your derived data every time you build your project. This happens both on CI if you're using Xcode build, and both locally if you're using Xcode to compile the application. You will then add a post scheme action that invokes XCMetrics. This will be, again, executed both on CI and locally. And the job of this post scheme action is to fetch the XC activity log through XCMetrics and save it somewhere safe, so that even if you clean your derived data, the previous builds will be stored by XCMetrics locally. So this makes sure that all of the builds that your developers are doing will end up in your metrics collection, so that you won't lose any builds. After fetching the metadata via the plugins as well, that can be optionally provided, the log and the metadata are uploaded by XCMetrics automatically to the backend that you specify. The backend is a backend instance of XCMetrics running in the cloud, which receives the log and saves the log to GCS to make sure that the file is stored safely. Then XCMetrics proceeds to enqueue a parsing task in Redis. As we said before, the XC activity log can be a pretty big file, so it could take a few seconds to parse it out. So in this way, we make sure that we can either asynchronously or synchronously parse the log. And as soon as the task is ready to be executed in our backend service, we can fetch the log file from GCS, parse the data, and insert the data into a PostgreSQL database, for example. And after this, the possibilities are infinite. You can have all the data in your database, and you can start to build dashboards. You can build queries. You can build alerts in order to make sure that the developer experience is what you think it should be. So now we're going to see how to integrate it really quickly. The first step is, as we showed before, to run XCMetrics in a post-action scheme. We're now going to use a small demo project, which is the Kickstarter open source iOS app, to add XCMetrics. We can edit the scheme, add a post action, add a run script action. We can provide the build settings from the app so that XCMetrics can actually fetch some important build environment variables, and then we can just execute XCMetrics. After building a project, XCMetrics will run, and we can now see where the data will be sent.
Yep, that's right. So the second step is basically you need to deploy an instance of the XCMetrics backend. And Patrick already mentioned that we are using Swift in the backend to build the XCMetrics backend. And not only that, but we are all actually using the same project for both the client and the server. So basically, they share the same project. So when you open XCMetrics in Xcode, like we are showing in this photo, the code is all there. There is a group for the client, there is a group for the backend. They even share some code. You have two schemes if you look at them. And basically that was really useful because now you can use the same set of tools that you are used to use when you develop for iOS, but in this case for backend. And by that, I mean that you are able to debug the backend using Xcode. You are able to use etc test to write a test for the backend. You can even profile with instruments what the backend is doing. And the other cool thing about that is that we were able to parse the logs in the backend. I already mentioned that the log can be big in some cases, especially for clean builds. And if you run a log parser locally in all developers' machines, that can consume a lot of resources in some cases, and you don't want that. You don't want to interfere with the experience of your developers while you are actually measuring the experience or trying to measure the experience of them. So by using Swift in the backend, it was really easy to do the parsing in the server because Etsylog parser is written in Swift. So basically, we just added Etsylog parser as a dependency to the backend, and that's it. Now, all the heavy lifting of parsing is happening in the cloud, and it can take a few seconds, but it won't interfere with developers' machines. And the other cool thing that you can do here is to actually run the project. So you can either run it in Xcode. That's okay if you want to do some local testing of it. But after that, maybe you want to run it in the cloud. So we provide some Docker image for that already packaged for you. And then you can deploy it to any cloud provider. Probably the easiest way to do this is to use Google Cloud Run. If you don't know what Google Cloud Run is, a product from Google that allows you to run any arbitrary Docker image really easy in the Google Cloud. So we put the run on Google Cloud button in our repo. So if you go there and click, basically what's going to happen is that we are going to configure an instance of Google Cloud Run for you, ready to run XCMetrics. There are some caveats, of course. For instance, you also need to create a database because we store everything in our database, but we provide a lot of documentation about how to do that. So this is enough if you have a small amount of bills, but probably you work in a large organization like us and you need a more robust way to do deployments. Probably your organization are already using something like Kubernetes for that. So we provide a lot of documentations and even Kubernetes deployment configuration examples about how to do that, because that's how we run it internally. And once the backend is up and running, you can go and open the dashboard. Like in this case, this is a small dashboard that we did for this demo, and you can check all the information. In this case, there is already one build, the build that we ran at the beginning of the demo, and you can see stuff like the duration. It took 2 minutes. It had 120 something warnings. You can click on the warnings if you want. The build was successful, so that's good. And that's it. Those are all the steps that you need to be able to run XCMetrics in your infrastructure. So now, how can you use this? So imagine this case. Let's see one example. Imagine that an engineer in your organization is trying to build the app, and you already integrated XCMetrics, and she runs into a weird build issue, like in this case. So she's using Xcode. So that's good for her because she's able to see the error in Xcode. But then he tries to get this fixed, so asks you, and you are the infrastructure engineer, about it. If something's weird is happening locally, and you help me to troubleshoot this. And because you are using XCMetrics, this is actually pretty easy, because now you can do something as easy as open the dashboard and see, okay, this is the build that someone reported, and you can see the actual error, the same information that the engineer was seeing in her Xcode, but in the web dashboard. And this is pretty cool, and it's pretty useful. But I think one of the most powerful features is that we are actually storing all this data as well in a database in the cloud. So all this data that we mentioned, that we have thousands of lines that we extract out of Xcode, plus all the other information that we collect with XCMetrics, like which Xcode version are the developers using, which macOS version are using, which CPU are they using, is everything there. So imagine that you want to know okay, is really Apple Silicon faster than Intel CPUs? Well, the information is there. You can go there and do a query and find out by yourself. And with that, you can also extend XCMetrics and build some tools to visualize the data in the way that you want it. So let's see an example. At Spotify, we use Backstage. Backstage is our developer portal that is also open source. And we built this plugin for it. So this plugin shows the build times percentile history of the music app. So you can see all the build times in the last 3 months, in the last year, the last 30 days, and so on. So imagine that someone introduced a change in the build settings for some reason, and that person wants to know, okay, what was the impact of this change? Or imagine that you switch to Xcode 12 and you want to know if that impact the developer experience or not. Then you can build a dashboard like this one, and you can see everything visually very easily.
So how do we use the data? So as we mentioned, we gave a few examples of like use cases where these kind of data are useful. So we are able to get a lot more insights compared to before about the developer experience. We can even set up alerts to make sure that the developer experience is what we expect it to be. We can make sure that no more than 10% of the people are having errors every day. Otherwise, probably something is wrong in our project. And we can set even different alerts for CI and local builds. We probably know that CI may fail less than what developers do, since developers are doing a lot more incremental builds locally. And in this way, we can also track build times trends and predict them. We can know what do we expect build times to be when our project will contain 1 million lines of Swift code, because we can analyze how long the Swift code in our project is taking compared to how long the Objective-C code part is taking in our project. We can also spot build time and code quality regressions. For example, in the past, we found some Swift functions that would take up to 10 seconds to type check. In this way, we can be alerted about these kind of like misbehaviors and fix them very quickly to prevent our customers to actually experience these issues. And as Eric mentioned, we can answer very interesting questions such as which hardware is the best to compile our project. We don't need to benchmark everything ourselves, but we can get the data out in the wild and see in real life which machines are the best to compile our project. And we can then even see if there are regressions in new Xcode versions. For example, some developers may decide to upgrade to a newer Xcode versions and they may experience some problems, and then we can track down those problems to be an Xcode bug instead of a bug in our project. We can also monitor which targets are the slowest to compile and go and talk to the actual team members to make sure they can address that and make the project faster to compile for everyone else. And we can also collect all the deprecation warnings or every other warning in general and assign them to the right team that owns that feature to make sure that the code health of the overall project improves and stays the way we expect it to be. So here are some results at Spotify. We've been running XCMetrics for a little bit over a year now, and it has collected over 1 million builds and about 10 billion steps. So steps can be very granular. It can be even down to a file compilation. So we know which file failed to compile or how long that file failed to compile for the last year and more. And this was applied to all the Spotify iOS applications. So it sums up to over 11 terabytes of data. So it's definitely a lot of data, but it has allowed us to make informed decisions in regards to our project structure and architecture. So even going forward, we know that if we do one change, we can rely on XCMetrics to make sure that this change does the improvements that we expect it to do. And of course, we didn't remove the person-to-person feedback. We still get surveys, answers from our developers, and we still do one-to-one meetings with them to understand how they're feeling and how the experience is like in their everyday, day-to-day job. But XCMetrics has allowed us to deliver even more and effective products to our developers. So we're really happy about it. And our mission is always to try our best to take data-driven decisions and measure the impact of our changes. So XCMetrics definitely helped us in that mission. So we are very happy today to open source XCMetrics, and we hope it will help also your organization to make sure that you will improve your developer experience as much as you can. So feel free to head over to github.com/spotify/XCmetrics to check out the documentation and all the examples that we have there. And yes, we're also looking forward to your contributions. Thank you very much.